In this video, we're going to explore how to solve a system when there are three variables. In the problems we've done before, we've seen x's, we've seen y's, but now we have a third variable with z here. And we need to figure out how in the world we're going to use what we know about systems to solve for all three variables. So the first thing that we're going to do is we're going to take one of these equations. I am just going to start at the top. And we're going to try and get one of the variables all by itself. So here I have x minus 5y plus z equals 16. I'm going to try and get the x by itself. So I'm going to add 5y here. I'm going to add or subtract z here. And I'm going to do the same thing over here. Plus the 5y minus the z. All right, and this part is going to cancel out. So I am left with just x equals 16 plus 5y minus z. Now, once I have that, I'm going to focus in on the other two equations. But everywhere I see an x, I'm going to be writing this problem here. And it's going to let me get down to just having two variables, which is what we've been working with. So let me just rewrite the first one. Instead of writing x, 2, 16 plus 5y minus z plus 3y plus 4z equals 18. I'm going to do my distribution. 32 plus 10y minus 2z plus 3y, bring everything else down, plus 4z, still equaling 18. All right, and if I match my like terms up, and just bring this minus 32, bring it over here to the numbers, 18 minus 32 is going to be a negative. And then I can combine, here I have 10y, a positive 10y, and 3y, that is 13y. And then I have negative, because you take that sign in front of it, negative 2z plus 4z. That's going to be a positive 2z. So I have 13y plus 2z equals negative 14. And I'm going to do a similar process with the third problem here. All right, so it was x, so that's just going to be 16 plus 5y minus z plus y minus z equaling, I think that is negative 8, but I'll just move my arrow just to make sure. Negative 8. All right, and I'll combine what I can. So it's a positive 16. There's nothing to be multiplied, so I can just start moving things around. Negative 8 and negative 16 is negative 24. All right, I have 5y here plus y. That is 6y. And I have negative z minus z, so minus 2z. Now I have two equations that have two variables. And I could solve it through substitution. I could also solve it through linear combination. I'm going to choose linear combination, and I'll show you why in a moment. So I already have this equation right in here. I'm going to write the other one right underneath it. 6y minus 2z equals negative 24. The reason that I'm going to choose linear combination here is you might notice that these are already going to add to 0. So I don't even need to multiply because I already have the positive 2 and the minus 2 for z. So 13y and 6y is 19y. And negative 14 and negative 24 is negative 38. We divide by 19 on both sides. Please add it in there. And I get that y equals negative 2. So if we know that y is negative 2, we're going to go back and we're going to use one of the equations that we have that just has y and z in it. I'm going to use, you could use either one of these that are in this system we've created. I'm going to use this one, the 6y minus 2z equals negative 24, simply because I have space to write underneath, but you could use either one. So 6 times negative 2 minus 2z equals negative 24. 6 times negative 2 is negative 12 minus 2z equals negative 24. I'm going to add 12 because that's the inverse of negative or minus. Add 12 to both sides. Negative 24 and 12 is negative 12. Remember to bring that sign down, negative 2z. You always take that sign with it. We're going to divide by negative 2 on both sides. And I now know that z equals 6. All right, so I'm going to circle those pieces. I know y, I know z, and now that I have that, I can solve for x. And we're going to come all the way back up here. And I'm just going to put y and z's value in. So 16, x equals 16 plus 5 times y. We said that's negative 2. And minus z, that's 6. And we could put that straight into a calculator. 5 times negative 2 is negative 10. 16 minus 10 is 6. 6 minus 6 is 0. So x equals 0 here. So now I have all 3 of the variables, x, y, and z, and we write our answer just like we did before when we had x comma y. We're just going to do x comma y comma z. So x goes first, that's 0. I have y, which was negative 2, and I have z, which is 6. And here is our final answer. And if you go ahead and you substitute 0, negative 2, and 6 in for each one of those, you will in fact find out that they work for each equation.